an estimated 4 million injuries per year. 4 million injuries per year, some resulting in death from ladder falls. 4 million. Hey, welcome back. Today we're looking at a completely automated, pure Python-driven engineering asset built entirely inside FreeCAD for one purpose: to improve safety, OH&S safety for climbers on ladders. If you look at an Australian risk assessment, there's a massive blind spot. They rely entirely on qualitative guesswork, picking an arbitrary likelihood and consequence off a colourful 5x5 grid. They completely ignore the actual Newtonian physics of the hazard. This macro bridges the gap by replacing the guesswork with predictive, physics-based risk assessment. Every mechanical force is bound directly live to a spreadsheet. Look at the 3D viewport. As I adjust the climber's position, these custom harpoon arrows calculate the risk in real time. You are looking at live vectors for a wall reaction, ground normal force, and the critical split arrow tracking against the slide and the available friction from the different ground conditions. It turns risk assessment into an exact mathematical certainty before anyone even steps onto a rung. You never exceed the maximum rated capacity of a ladder. The second, maintain a strict 4:1 ratio. The horizontal offset of the base should never exceed a quarter of the vertical extension height. Number 3, ensure the base is fixed. Relying on friction alone is incredibly risky. Double check it if you have to go up a ladder unsecured. So that might be going around to the other side or the underside of the ladder and hanging off a point as high as you can get and assessing its stability before attempting to go up. Number 5, fly off the top of the ladder to eliminate lateral side-to-side displacement and dropping. 6, use a spotter. The spotter can steady the base and hand items up, letting the climber maintain the 3 points of contact essential for safe climbing. And 7, never stand on the top rung. This is where stability plummets and the risk of rail buckling skyrockets. These rules are proven standard for keeping people safe on site. What this macro does is also takes those operational guidelines and elevates them by providing why they work using real physics. So if we just go back into the risk assessment for a quick visit, we can see that the risk assessment can be signed off by up to 4 people, 5, including the person who. So the idea is that one person does it, the other 4 people understand it. Understanding guesswork, which is pretty crazy to me. But the whole system of this guesswork has been initiated by hierarchy, the government. The government has told you to go to work and be unsafe, to guess what you're doing, which is crazy. Absolutely crazy. It's a roll of the dice. And it doesn't matter how many times you roll the dice, it's guesswork. Okay? So if you review it, it's guesswork. If your colleague reviews it, it's guesswork. If the person who printed the page, or the person who owns the factory, the person whoever, whichever supervisor, whichever foreman reviews it, it doesn't matter. It's guesswork. And to some extent, it's always going to be guesswork, and it's always going to be a roll of the dice. A roll of the dice. No matter how many people have reviewed it. So this macro, this concept, the entire presentation is to hopefully get people to slow down and not get hurt at work, because I was one of those people who got hurt at work. So if you come across this video and macro, please buy it. I could really use the help. I can't work because I got injured at work. That's right. My parrot just called me an arsehole outside. Anyway, the point is there. I'm an arsehole who can't go outside anymore because I got hurt at work. So I'm trying to use my downtime to help people not get hurt at work.